the second attempt to warm up that connection for a half hour and then hit it with cryos in order to get the bullnose connector to reseat in the seal did not work. LHY, the liquid hydrogen team, reporting to the NASA test director that as soon as they resumed flow, when they added any pressure at all, they saw the leak return. The launch team has presented a recommendation of no-go for launch to the NASA test director and launch director. We are currently waiting a decision. Launch director Charlie Blackwell Thompson, addressing her team just a few minutes ago, says she has received their no-go recommendation but wants to hold off. Some additional thoughts and conversations are being developed. Launch director Charlie Blackwell Thompson just called a scrub for the launch attempt today, the second launch attempt. Again, launch director Charlie Blackwell Thompson calling a scrub for the day here at the Kennedy Space Center Launch Complex 39B.
Disappointment for the Artemis team at the Kennedy Space Center as the second attempt was scrubbed at 11:17 a.m. Eastern, about 3 hours before the opening of the launch window, by a large hydrogen leak at the 8-inch umbilical quick disconnect. The leak was up to 3 times greater than the redline flammability concentration of 4%, much higher than a similar but manageable leak on Monday. Controllers made 3 tries to troubleshoot the leak, with no success. In the late afternoon press conference, Artemis mission manager Mike Sarafin reported that an erroneous valve command lasting a few seconds raised the hydrogen line pressure to 60 psi, compared to the limit of 20 psi. The possibility that this overpressure damaged the soft goods of the seal causing the leak is under consideration, but data analysis about the leak is just beginning. He said the error would not have damaged the rocket. Software will be written to automate this process before the next attempt. Officials will consider next steps early next week. This launch period, which ends on Tuesday, is off the table. One option for repairing the leak is to inspect the connection and change out the soft goods at the pad while protected by an environmental enclosure, and then conduct a hydrogen-only cryogenic test. This would amount to a very limited wet dress rehearsal, with chill down, slow fill, and a small period of fast fill to test for leaks. In the second scenario, the rocket would be brought back to the VAB where working conditions are controlled, but a cryo test would not be possible. The next launch period runs from September 19th through October 4th and is known as LP26. Beyond that, LP27 begins on October 17th and lasts until the 31st. The leak repair is not the only factor in scheduling. The Range Safety Destruct Explosive System, called the Flight Termination System or FTS, has batteries and circuits which need to be retested at regular intervals. The current certification for 25 days, which was already extended by range officials from 20 days, will expire. Unfortunately, FTS work can only be accessed in the VAB. Unless NASA gets a rather long, and quite frankly unanticipated, extension, a rollback cannot be avoided, and the target would then become October 17th. Here are the pertinent excerpts from the briefing.
We will deconflict with Crew 5, so there is an overlap with our next launch period and the time frame when Crew 5 wants to go. We need to make sure we deconflict with them.
At this particular time of year, a high propellant bulk temperature, which gives us more performance out of the rocket. So essentially we have a hot rocket in terms of the performance to launch, and that actually, as we fly up through the Earth's atmosphere, pushes the higher end of the maximum dynamic pressure, or Q bar. And we saw that we had positive margins, but lower margins on one specific area on the Orion spacecraft, and we were watching that. The vehicle was expected to get to about 700 pounds per square foot of pressure as it headed up through the period of maximum dynamic pressure. The team was working through a chill down, and there was an inadvertent pressurization of the hydrogen transfer line, that the pressure exceeded what we had planned, which was about 20 pounds per square inch. It got up to about 60 pounds per square inch. And the flight hardware itself, we know, is fine. We did not exceed the maximum design pressure, but there's a chance that the soft goods or the seal in the quick disconnect at the 8-inch quick disconnect saw some effects from that, but it's too early to tell exactly whether that was the cause of the hydrogen leak that we had today. What we do know is that we saw a large leak at the 8-inch quick disconnect today, and that leak started when we went from the slow fill to the fast fill. This particular quick disconnect did not have a problem of this magnitude on Monday. We did see a small leak, but we did not see one of this magnitude. It was characterized as a large leak by our operations team. The team tried 3 times to resolve the leak, and all 3 times we saw a large leak. And as was discussed previously, if you can thermally stabilize both sides of that quick disconnect, we have a ground side and a flight side, and that is where the fluid flow occurs through. If you can chill that down and ensure that there's no differential temperature across that interface, sometimes the leaks can seal themselves or heal themselves. So the team attempted that. They attempted to essentially reseat the leak by increasing the pressure in there, and that was not successful. The team leaned towards a removal and replacement of the soft goods in the quick disconnect, and the options were basically to do it at the pad or do it back in the vehicle assembly building. And either of those options do not preserve our ability to fly before the end of this launch period, which expires on the 6th. So the team is developing a series of schedule options, and we're going to hear about those early next week. The schedule options include removal and replacement of the soft goods on the quick disconnect at the pad, followed by a cryo test. That is the only place we can get a full cryo test to ensure that we do not have a further issue with respect to leaks at the temperatures that we need to fill the vehicle on day of launch. The other option is to roll back and remove and replace the quick disconnect soft goods in the vehicle assembly building. There's a risk versus risk trade. Doing it at the pad, you're exposed to the environmental conditions, and we need to build an environmental enclosure to do that. If we do it in the vehicle assembly building is the environmental enclosure. However, we cannot test this quick disconnect in the VAB at cryogenic temperatures. We can only do it at ambient temperatures. Yeah, and Marcia, with respect to whether or not September, the latter part of September is still in the trade space, again, I think it's too early to tell. It really comes down to what does the fault tree analysis tell us, and what are the necessary changes and mitigations required in order to have confidence that we've resolved this large leak at the 8-inch quick disconnect. So I think we'll have a much better answer early next week, and right now it's just too early to tell.
Yeah, for the VAB part of it, it's what I said. We have to go back right now. We do not have an agreement with the range that we can launch when our batteries have not been tested after 25 days. So that runs out here, as Mike said. And so in order to change them out, we have to go back. To get that kind of extension with the range is something we'd have to talk to them about. So right now our position is we will have to go back to the VAB. When we go back will depend on the testing options that Mike talked about. No, because it's really their call. And I think we have data that probably supports it, and I know our folks are going to go talk to the range as soon as they're able to. But that's really, that's serious business that they deal with and we deal with, and we want to respect that this is their range and we're launching from it.
We will also have some witness information when we demate the umbilical. We're being very thoughtful about demating the umbilical at this point, because we also don't want to disturb what may be critical engineering data as part of that. So before we proceed into a simple what we think may be a simple removal and replacement of this quick disconnect seal, we want to make sure that we're not overlooking something. So we're going to take some time to go through this from an engineering standpoint, go through any potential cause or exclude any potential cause based on the information we had. So it's a little too early to tell exactly where we may need to do some work. So the quick disconnect, it's a metal poppet-like device, and it has a gasket around it. And I don't know the exact gasket material, but if we were to see damage on the quick disconnect, that would tell us we would need to replace the hardware. If we saw foreign object debris, that would tell us that maybe we got something else going on. Or if we just saw simple damage on the gasket, we've got spares, we can quickly remove and replace that. Our history of our own testing at the Launch Equipment Test Facility, which is right here resident at the Kennedy Space Center, tells us that a leak of this magnitude is typically resolved through a removal and replacement of the soft goods, that seal, and that's kind of one of our leading suspects right now. But again, we need to go through the fault tree. We need to inspect the hardware. We need to see what the hardware is telling us. So in terms of exactly what needs to be done, it's too early to tell. And I'm sorry, there was a second part to your question. I don't recall what the second part was.
About the enclosure. About
the enclosure, yeah. So the enclosure affords us the ability to provide what we call a purge at that interface, and the purge allows us to push nitrogen in there to essentially inert or push out any oxygen in there, so it reduces the likelihood of a flammability hazard. So if we were to just pump regular old air in there, regular old air has oxygen in it, and we eliminate that oxygen by creating an enclosure and putting nitrogen in there to displace any oxygen, such that if there is a hydrogen leak, you've got one leg of the fire triangle removed. We're still reviewing the data and the sequence of events, but as I understand it, it occurred during the chill down prior to the loading operation associated with loading the liquid hydrogen and liquid oxygen, and it was part of the preparatory steps, and there was a sequence of about a dozen commands that were required, and it was simply the wrong valve was commanded, and it was identified after about 3 or 4 seconds, and then it was rectified. So that's what we understand. We know what the pressure profile looked like at this particular interface, and we're looking at again the sequence, and as was mentioned by our lead project engineer earlier today, you know, we want to be deliberate and careful about drawing conclusions here, because correlation does not equal causation. So we are taking a look at the inadvertent overpress, and we're looking at what that meant to this particular interface, and then we're looking at the fault tree associated with the leak that we saw, and if there is a conjunction of potential causes on the fault tree, then that'll take us down one path. If there is no root cause that you can trace to that, then that'll take us down a different path. So again, it's a little early to tell. We've looked through quite a bit of information already, but we got to work our way through this one, and we're going to do it methodically.